everyone. Today we are going to learn 4.2, the least squares regression line. So we have a learning objective here. Let's take a look. Important point here. We talked about the correlation last time, right? So if correlation is significant, we can draw the line. If not means if not significant, we cannot draw the line. So what line we are talking about? So let's take a look. So we have a scatter plots here, right? So if we have two quantitative data, then we can plot the scatter plot, right? So scatter plot all over the place. Now, how do we draw the line? This is the explanatory variable is, which is x, total fat, right? And we have the y-axis, which is responsive variable, which is a protein, right? Let me write down. We cannot see. Okay, here we go. Okay, so they say that draw a line that fits the data, right? So how they make the line, straight line they talk about, right? Fit the data, right? So is this one, or is this one, or is this one? Yeah, let's take a look. So we have three types here, right? So if we draw the line this way, then the line is too high on the left, too low on the right. The left side is too high to make a fit with the data set, right? Okay, now if we draw this way, then left side is too low, right? Right side is too high. It's opposite of this one, right? Then we have to make a middle of this line to make all the data set make a best fit there, right? Ta-da-da! How about this, right? So is it this not too low for the left side, not too high for the right side, right? So this is best fit for the old scatter scatter plot for the line. Okay? Okay. Then why we need this one? Why we need why we need concern about this one, right? So basically we want to estimate, we want to predict when x equal to something, we know y equal to something. We can guess, right? So in that case, total fat, we don't have a data set when total fat is 30. If we have a line, which is a straight line, right? Straight line, we learn a lot from algebra course so many times, right? From the elementary algebra, intermediate algebra, right? Okay, then we have equation for straight line. If we total fat 30 grams, what is protein in there, right? Because most meat has protein and fat together, right? Then if we have equation, in that case, just by looking, right? We have 30 total fat, then there is a protein is 20, little bit less than 30, so 29 grams, right? So why we need to best fit the line? Because we want to predict the response variable by given explanatory variable, right? Okay. Is it there residue here? even though our title is regression squares, regression, least squares regression line, right? I'm gonna explain to you why they're using this terminology, the vocabulary later on, later section. Yeah, because we need to learn about the residual so that I can explain to you better. Okay. All right. Now let's review about the line. So we talk about the line, straight line earlier, right? So least squares regression line is a straight line, right? So we want to make a best fit among the scatter plot, right? So how do you make a best fit? So let's review the straight line. So we have that form, which is slope intercept form, which is the linear equation, right? So let's take a look. We have m equal to slope, right? And b is the y-intercept. That's why the name of this equation, we say that slope intercept form. Slope intercept equation, right? Yeah. Or form. Okay. We have example 2. Let's take a look. So U-Haul moving truck rental company charges $29.95 plus $1.19 per miles to rent 15-foot truck. Okay, now let x equal to number of miles truck is driven and y equal to total cost to rent, right? The truck. Okay, then we can say that y equal to 1.19 per miles, right? So x, because x is the number of miles the truck is driven, right? Plus $29.95, right? Okay. 0 miles, even though they didn't drive anything, they have to pay almost $30, which is $29.95, right? Yeah. But if they drive only 1 mile, then extra charge $1.19. Yeah. That is $91.14. Yeah. Okay. How do we draw the line? We can use slope method, right? Okay. How? We start from y-intercept, right? So this is a y-intercept. This is a y-intercept. Let me denote it this way, right? And this is a slope, right? Which is m, right? Slope. Okay. Oh, it's hard. Let's take a look. So y-intercept, which is 0 and 29.95. We start with, right? So that is 29.95, right? And then slope, which is 1.19 over 1, right? Because we don't see any number, that means 1. So rise over run, right? So m equal to, which is rise over run. So rise means up or down, right? And then one is right or left, right? Okay. So in that case, it's positive. We going up and we going right. Yeah. So up and right. So that is from y-intercept 1.19 over 1, 1.19 over 1, 1.19 over 1, 1.19 over 1, 1.19 over 1. Yeah? Okay? So we have the point, and then we're using a ruler and make it extend. Yeah? That's how you drew in the algebra course, right? Remember? Okay, very good. Okay, then let's go back to least squares regression line, which is fitted line or trend line. Okay, so we have the formula for that. It's equation, right? So like y equal to mx plus b form, if we have that equation, we can draw the straight line, right? Same as here. So we have least squares regression line, which is trend line, which is a fitted line in the StatCrunch, right? So fitted line. Then we have that equation. Let's take a look. This is the equation. Highlight better. So this is the equation. Yeah. Y hat equal to b sub 0 plus b sub 1 x. Yeah. Okay. Look. Uh, we called this one b naught. Read b naught or b sub 0 subscription. We know that, right? And then we call this is a b sub 1, right? B sub 1. Okay. We read y with that, right? So we call the y hat. So this symbol, we read y hat, different color. This symbol, y hat. So they say the head means head is telling us estimated or predicted value. From the trend. Okay. All right. Then we can see the b sub 1 is in front of x. So like mx plus v, right? So mx, so m equal to slope, right? So b sub 1 x, so b sub 1 is m as well. That is the slope, okay? So this is the slope. Okay, then we can guess b naught, b sub 0, right? So what is that? That is y-intercept. Good job. This is the y-intercept. Yeah. All right. Okay, so let's do this example. So we have total fat versus protein like earlier, right? And then we have the equation, which is y hat equal to 5.9 plus 0.71x, right? Okay, use the regression line to estimate the amount of protein in a fast food meal containing 30 grams of total fat. So we had earlier, right? When total fat is 30 grams, what is the protein in that grams, right? In this case, right? Now, we want to solve, like estimate, predict the y value, right? By the equation. Earlier, we're just looking at the graph, right? And second part, interpret the slope and y-intercept from the equation. Okay, let's do it. Let's write down. A, we have y hat equal to 5 point, different color. Y hat equal to 5.9 plus 0.71x, yeah? When x equal to 30 was a y value, right? So when x equal to 30 grams, right? So we have a y hat equal to 5.9 plus 0.71. Now your turn, can you please calculate? Okay, so 27.2. Okay, so we got the 27.2. All right, so that means when protein is 30 grams, we get the protein 27.2, right? So like earlier, let me write down. Okay, so I'm gonna read. This means the fast food containing 30 grams of total fat will have around 27.2 gram protein on average. What this mean on average means, right? So we cannot have exactly 27.2 grams of protein. It can be 27.1 gram or it can be 27 grams. So it's on average. Make sense? Okay. Let's do second part. Second part said interpret the slope and y-intercept. Okay, so let's talk about the y-intercept first. So y-intercept is a 5.9, right? Okay, that means when x equal to 0, then 5.9. Yeah, on average, right? Okay, make sense? So we cannot have exact amount 5.9 protein, right? So that's why we say that it can be 6.0 grams of protein or 5.8. So we said on average, right? All right. Then the book said that x equal to 0. So what is x? X is the total fat, right? So we cannot have a 0 fat, right? Looking at the fast food, we cannot have a 0 fat. There is some fat, right? So they say that the estimation does not really have any meaning. Make sense? All right. Let's talk about the slope. Slope is 0.71. That means when x equal to 1 gram, which is total fat, right? Then we get the we 1 gram for the total fat, then we expect the increase by 0.71 grams on average again, right? Makes sense? So this is a slope, right? So slope every time x increase, they increase by 0.71 grams on average. Yeah, let me write down. Okay, so I wrote down what I just said here, right? All right. Now, there's a tip. Normally we had y equal to mx plus b form, right? That equation. Then this is a slope first, then y-intercept. But then this regression line equation has the intercept first, then slope last, right? So that is the tip in the case. Why? Because StatCrunch gives us like that form. Yeah. Okay. Okay, now I'm gonna show you how to use StatCrunch. So I want to copy the data set, like this one, total fat versus protein, right? And then I'm gonna show you StatCrunch, okay? Okay, so I'm gonna show you how to draw the line, straight line, regression line by hand. And then I'm gonna show you the StatCrunch, right? Okay, so how did we draw the straight line in algebra course, right? So we make a table. We pick any random number for x, then we get the y value, right? So let us do that. I want to do when x equal to 10, when x equal to 50, 2 points. And then we have the y value, and then we connect to 2 points. That is regression line, okay? Let's do it. When x equal to 10, so we have y hat equal to 5.9 plus 0.71 times 10. Now, can you please calculate 13, right? Yeah, 13. Okay, oops, you didn't see that. Yeah. All right, so we get the 13. When x equal to 50, y hat equal to 5.9 plus 0.71, 50 equal to, can you please calculate? Oh, you cannot see. Yeah. It's a 41.4. Good. Okay, so we have a 13, no, 10, sorry, 10, order pair 13, and we have, let me write down different color. So we have a 10, 13, and 50, and 41.4, yeah? Okay, so 10 and 13, so this 15, 13, it's over here. Yeah. All right. Now 50 and yeah, recording. Always scared. So 50 and 41.4. So maybe it's over here, right? Okay. Yeah. Okay. So I want to draw the line. Yeah, little bit off. Yeah. Okay. So this is the line, regression line. That's how we do that. Okay, let me show you StatCrunch, okay? So we talked in the beginning, right? So if the correlation is not significant, then we cannot draw the regression line, right? So here, look at the scatter plot, right? Yeah. So that is not significant. So that we can just take a look, right? So in that case, we cannot draw the regression line and we cannot find the equation. All right? Yeah. So not significant. Make sense? Okay. Any question? So do not use a regression to predict about the data. Yeah. All right. Okay. Thank you for watching. See you in the next video. Thank you. Bye.